Hello. Good morning.
Morning, sir.
Is it audible?
Yes, sir.
Okay. In the previous class, I have discussed about shear strain, double shear, and then we have derived an expression for strain of a strain in a volumetric strain for a longitudinal bar of the circular cross section, and also for this one. This one for rectangular cross section and circular cross section. This also we have derived. So see, one thing I want to tell you. This derivation, what I have done, this derivation, what I have done here, I have taken this as pi, change in diameter as d minus delta d, and increase in length as L plus delta L. This can also be done on the same lines. That is, volume is equal to pi d square by 4. I can also take this as delta z the same way. Let me show that. Same as here, delta z is a function of dou z by dou x into delta x plus dou z by dou y into delta y. Similarly, you can say dou v is equal to dou v by dou l into dou d into dou d plus dou v by dou l into dou l. That can be also done in the same way. Since I want to show that, I have done in that way. You can do in either ways. This which are comfortable for you, you do it in that way. Okay. Next, we have to. I told you we will discuss about generalized Hooke's law. Can anybody state Hooke's law? Can anybody state Hooke's law? State Hooke's law.
Stress is directly proportional to strain under elastic limit.
You should say proportional limit. Stress is directly proportional to strain within proportional limit. That is
Proportional limit.
within proportional limit. Okay. That is, stress is directly proportional to strain within proportional limit. That was only the loading was axial. That was on the loading was only in the x direction. If I consider the bar like this, if I consider bar like this, and we have assumed the loading was along the axis like this, P and P. This is generalized Hooke's law in one dimension. Sigma is equal to n smallest times epsilon in one dimension. But what happens when the loading is multi-axial? There is along x, y, and z axis. When the loading is multi-axial like this is called as a cube. Generally, we call it as parallelepiped. When the loading is, this is P. Assume this is, for example, you can also take, instead of load, I can also indicate it by stress in x direction. Stress, this is P, this is P, this is P. Any load, it can be any load. P, P. When the loading is multi-axial, I cannot write sigma is equal to Young's. I can write it, but I should write in 3 dimension. The expression or the formula or the expression which relates stress and strain in 3 dimension is called as generalized Hooke's law. The Hooke's law, what we wrote in the previous section, was only for 1 dimension. The loading was along the axial direction. When the loading is along 3 direction, the stress and strain are related by three equations, or for three-dimensional loading, the stresses and equations is called as generalized Hooke's law. Okay, that what you have to understand is, for one dimension we know Hooke's law remains the same. Stress is directly proportional to strain within proportional limit. But when we apply this Hooke's law for multi-axial loading, the Hooke's law, what we called previously just a general Hooke's law, becomes generalized Hooke's law in case of three-dimensional loading. Okay, now let us go on. There is expression for that generalized Hooke's law. Now I will take same parallelepipede or a cube. Instead of indicating the load, I will indicate it by stress sigma x. There is no difference at all. Sigma x. The stress in y direction is sigma y. All are tensile. Stress in z direction is sigma z. And then similarly stress in z direction, this is sigma z. This is x, y, and z direction. Now let us take one by one. One by one. This is the first case I will take, the parallelepipede. We know before that, okay, whenever it comes, I will write that. We know that parallelepipede is like this. I'm taking only x-axis loading. This is sigma x, sigma x. If I write epsilon x is straightforward sigma x by e, sigma x by e, sigma x by e, and then nu is equal to lateral strain by longitudinal strain. Okay, since when I pull this, there's a decrease in dimension. Let me write this is minus nu. Similarly, nu is equal to in the z direction minus epsilon z by epsilon x. This is about my x direction. Are you able to understand this? Are you able to understand this? When I pull the rod, Poisson's ratio is given by lateral strain by linear strain. Since there's a decrease in dimension, I'm writing negative minus epsilon y by epsilon x. Similarly, there's a decrease in this width also, minus epsilon z by epsilon x. Decrease in depth, so the minus epsilon y by epsilon x. So this is longitudinal strain. Epsilon x is the longitudinal strain. When I take this is second part. Let us write sigma y, sigma y. In this case, linear strain is epsilon y is equal to sigma y by E. Poisson's ratio is equal to lateral strain. In this case, lateral strain is epsilon x. Linear strain is epsilon y. Similarly, lateral strain is epsilon z by epsilon y. In the direction of load, we have the linear strain. Other than the direction of load, we have lateral strain. There is epsilon x and epsilon z. Okay, hope you are understanding this. Let me write the third case, or I can also write this as, or minus nu times epsilon x is equal to epsilon y, or minus nu times epsilon x is sigma x by e is equal to epsilon y, and the same lines minus nu times epsilon x is equal to epsilon z, or minus nu times sigma x by e is equal to epsilon z. Same thing holds good here. Minus nu times sigma y by e is equal to epsilon x, minus nu times sigma y by e is equal to epsilon z. Next, let us consider third case of loading, third stress. This is sigma z. This is sigma z. I can write epsilon z. This is the linear strain, sigma z by E. Lateral strain nu is equal to minus epsilon y by epsilon z. Also, nu is equal to minus epsilon x by epsilon z. Z is the linear strain, y and x are the lateral strain. Or I can also write minus nu times sigma z by E is equal to epsilon y minus nu times sigma z by E is equal to epsilon y is equal to epsilon y. Sorry, is equal to epsilon z. Sorry, minus nu times epsilon minus 2 times sigma z by E is equal to epsilon x. Epsilon x. Okay. Now, if I write volumetric strain is given by epsilon x, strain in x direction plus strain in y direction plus strain in z direction. Epsilon x, let me add all these things. If I take due to this loading, the strain in x direction is this. Similarly, the strain in x direction is due to sigma y loading is this. The strain in x direction due to loading in sigma z direction is this. Let me club all these things due to this. Even though the loading is since the loading is the multi-axial, if due to the Poisson's effect, there will be strain in all the directions. Okay, let me club all this. Epsilon x is given by, let's write that, sigma x, or I'll write like this before that. Epsilon x is equal to sigma x by E minus nu times sigma y by E minus nu times sigma y by E minus nu times sigma z by E minus nu times sigma z by E. And the same length, if I write epsilon y, which is equal to epsilon y is equal to epsilon y, my epsilon y, this is one term, this is second term, this is third term. Let me club this, but I will take the linear term first. So this will be sigma y by E minus nu times sigma x by E minus nu times sigma x by E minus nu times sigma z by E minus nu times sigma, what is that? Sigma x by E minus nu times sigma z by E. Okay, let me write epsilon z. Epsilon z okay, epsilon z, which is equal to z component, linear component. This is the linear component. This is the linear component, sigma z by E, and then here minus nu times sigma x by E minus nu times sigma y by E. Let me write that. First I will write the linear component, sigma z by E and then minus 2 times sigma x by E, minus 2 times sigma x by E, minus minus 2 times sigma y by E, minus 2 times sigma y by E. Volumetric strain is given by summation of strains epsilon x plus epsilon y plus epsilon z, or I can write epsilon v, which is equal to sigma x by E plus sigma y by E plus sigma z by E, minus, there are two sigma x terms here, or let me write that, minus nu times, I will write this, okay, minus nu times sigma y by E, minus nu times sigma z by E, minus 2 times sigma x by E, minus 2 times sigma z by E, minus 2 times sigma x by E, minus 2 times sigma y by E. Let us club these things. Sigma x, this is one sigma x, this is one sigma x. Okay. This is sigma y, this is sigma y. This is sigma z, this is sigma z. Or I can write it as volumetric strain, which is equal to sigma x plus sigma y plus sigma z by E, okay, minus sigma x minus sigma 2 nu sigma x by E, minus 2 nu sigma y by E, minus 2 nu sigma z by E, minus 2 nu sigma z by E, or epsilon x, which is equal to sigma x plus sigma y plus sigma z by E into can I write this as 1 minus 2 nu, it's one and the same, 1 minus 2 nu sigma x plus sigma y by sigma z is this term, minus 2 nu is minus 2 nu minus 2 nu sigma x by E, minus 2 nu sigma y by E, minus 2 nu sigma z by E. This is the expression for volumetric strain for a parallelepiped array structure subjected to multi-axial loading. There is a loading in 3 directions. Okay. Did you understood this? Did you understood this? Did you understood this? Hello?
Yes, sir.
ಅರ್ಥ ಆಯ್ತಾ? ಯಾರು ಯಾಕೆ ರೆಸ್ಪಾನ್ಸ್ ಮಾಡ್ತಾ ಇಲ್ಲ? ಅದರ್ಸ್? Shruti, Mekala, Pratish Paul.
Yes, sir.
Did you understood this?
Yes, sir.
Shall I go ahead?
Sir,
Yes, sir.
We'll go ahead with the problems. The problem statement is like this. Determine the changes in length. Determine the changes in length, width, and thickness of a steel bar which is 4 meters long. which is 4 meter long, 30 mm wide, 30 mm wide, and 20 mm thick, 20 mm thick, subjected to axial pull of 30 kilonewton, 30 kilonewton in the direction of length. This is the direction of length. Take Young's modulus C is equal to 200 into 10 power 3 Newton per mm square. This is 200 GPa. And Poisson's ratio nu is equal to 0.3. Also determine the volumetric strain, change in volume, and final volume. This is the problem. So generally we ask for 8 marks or 6 marks. So this is the bar problem. Whenever you ask like this, straightforward we can find delta L or DL is equal to PL by AE. I know the load 30 into 10 power 3, length is 4000 mm, area of cross section I have to take B into T, 20 into 30, Young's modulus, it's 200 GPa. Can you tell me what is DL? Tell me what is DL? Sugun, Sushil, Kumawat, Patish Paul, Abdul Razak, Rakesh, Raghavendra. Are you calculating? What is DL? What is DL?
1, sir.
1 mm. Huh? Yes, 1 mm. Okay. Now, if I know DL, what else I can find? What I can find? Strain I can find, right? Straightforward you should say. I can find strain in x direction DL by L, which is equal to 1 mm divided by length 4000 mm. Can you tell me what is this? It should be consistent with the units. You should not take the DL in 1 mm and substitute the length in meters. 4 meter, you will get 0.25. How much?
0.00025.
0.25 into 10 power minus 3?
Yes, sir.
0.25 into 10 power minus 3. Okay, Poisson's ratio is given by lateral strain by linear strain. Either it can be, don't worry about the sign at the time being, either it can be epsilon y by epsilon, in this case is epsilon x, or nu is equal to epsilon z by epsilon x. For both the terms, it holds good. Epsilon y and epsilon z. Lateral is epsilon y and epsilon z. The ratio of lateral strain to linear strain remains the same irrespective of the load. We provided that the load is within the proportional limit. Load should not exceed beyond the proportional limit. Okay. Next, I know nu is 0.3. I know epsilon x. Epsilon x, it's how much? 0.25 into 10 power minus 3. 0.25 into 10 power minus 3. Or epsilon y. Can you tell me what is epsilon y? You can also, if you want, you can indicate it by negative sign. Since there's a decrease in that dimension, epsilon y is thickness direction. Thickness direction is decreasing. You can indicate it for your confirmation.
Point 0.075 minus 0.075.
Okay, epsilon y, which is equal to minus 0.75 into 10 power minus 4. Okay, epsilon z is also the same. Epsilon z is also the same. Epsilon y is given by delta d by d. I know epsilon y, which is equal to minus 0.75 into 10 power minus 4, which is equal to delta d by depth. It is 20 mm. Can you tell me what is delta d?
1.5.
1.5. Check it out. Depth. Nice. 1.5. You should tell me the proper full values. You should tell me 1.5 into 10 power minus 3 mm minus 1.5 into 10 power minus mm or 1.5 into 10 power minus 3 mm decrease in depth decreases. Okay. I can also write minus 0.75 into 10 power minus 4 is equal to delta b by b, that is the z dimension, or minus 0.75 into 10 power minus 4 into 30 is equal to delta b. Can you tell me what is delta b?
(22.5 into 10 power minus 4).
Shall I write?
Yes, sir.
Minus 2.25 into 10 power minus 3 mm, or delta b, there is a decrease in depth, 2.25 into 10 power minus 3 mm, decrease in width, sorry, decrease in width. Okay, I'm left with 10 minutes. Shall I engage one more hour? Another 40 minutes. After this class, I will stop. And shall I continue for another 40 minutes? Is it okay? Is it okay? Please tell me, shall I continue or not? Shall I continue or not?
Sir, some other day you take, sir.
Others? Please tell me, because you should tell me I am in a flow. I will finish off the problem. That's what I am asking. Don't want?
Don't need, sir.
Others, ಇನ್ನೊಬ್ರು ಬೇರೆ ಒಪಿನಿಯನ್ ಕೇಳಿದೆನಪ್ಪ. Others? Others tell me. Mekala, Dhruti, Raghavendra, Pratish Paul, Abdul Razak. Others?
Sir, I will say, sir. Don't need.
Other day? Okay. Sunday, tomorrow, is it okay? Tomorrow?
Okay, sir.
Okay?
Sir, tomorrow 1 hour class, sir.
Yes? Yes?
Tomorrow 1 hour class, sir.
Zoom permits generally only 40 minutes.
Okay, sir. Tomorrow, sir.
Okay. Okay, we have found out epsilon this one delta B, delta L, delta D. See, if you recall the formula, we have found it out. This first part we have found it, delta L, delta B, delta T we have found it out. We should find the volumetric strain epsilon V, delta V, final volume. Epsilon V, I will straightforward. If you recall this, for a rectangular cross section or circular cross section, the formula remains the same. This is epsilon V is sigma x by E into 1 minus 2 nu, or epsilon V is epsilon x into 1 minus 2 nu, or dl by L into 1 minus 2 nu, either for rectangular or circular cross section. You can see here, it's one and the same. E epsilon x, or this one dl by L epsilon x minus 2 nu, or this one and the same. Okay, this is one and the same. I can write one and the same. You can see here, epsilon x into 1 minus 2 nu is one and the same, minus 2 nu into, sorry, minus 2 nu. Okay, okay, I'll come to this. I'll come back to this. Give me a moment. Epsilon minus 2 nu. I'll come back to this. But for time being, this is given by sigma x by into 1 minus 2 nu. Volumetric strain, which is equal to sigma x by E into 1 minus 2 nu, are also given by epsilon x into 1 minus 2 nu. Epsilon x we know is 0.25 into 10 power minus 3. 0.25 into 10 power minus 3 into 1 minus 2 into Poisson's ratio. Poisson's ratio, it's 0.3. Therefore, 1 minus 0.6. Can you tell me what is volumetric strain?
Zero 0.1 into 10 power minus 3.
0.1 into 10 power, or shall I write 10 power minus 4?
Yes, sir.
Yes,
10,
sir.
10 power minus 4. Volumetric strain is also given by change in volume by original volume, which is nothing but epsilon x plus epsilon y plus epsilon z. It is nothing but delta, sorry. This is not delta. This entire thing is equal to epsilon x plus epsilon y plus epsilon z. Forget about this. But epsilon v we know 10 power minus 4. Let me write a volume is equal to L into B into D, which is equal to 30, 20, 4000. 4000 into 30 into 20. Tell me the volume. What is that? 12, 12 is that 24. How much? 24 into 10 power 5. What is the unit? What is the unit?
Mm cube.
Mm cube. 24 into 10 power 5. Mm cube. This is the volume. Therefore, let me write epsilon v 10 power minus 4, which is equal to delta v into 24 into 10 power 5, or delta v, which is equal to 240 mm cube. And he has asked the final volume. Final volume, since it's a positive quantity, it means to say that increase in volume. Increase in volume. Final volume is equal to initial volume plus change in volume. Initial volume, it's L into 24 into 10 power 5. Change in volume 240. Can you tell me the final volume?
24 into 10 power 5.
Just a minute. How much? How much?
24 into 10 power 5.
No. You club everything and tell me the full value. It is only 250. 24 into 10 power 5 plus 240. You should tell me. Yes.
24000240.
24002400 mm3. This is the final volume. This type of problems are generally asked for 6 to 8 marks. Okay, I'll continue with the other types of problems in the next class. Okay, another 2 class. This part will be over. Then Poisson's ratio, Young's modulus relation between that will complete in the future class. Next week I should be able to complete the first module. Any doubts you can ask me. You can ping me. You can mail me, or you can ask in the Google Classroom. Okay, thank you.
Thank you, sir.
Thank you.
Thank you, sir. Thank you, sir.